Hi friends, welcome back. Today we are going to solve one hard Google coding interview questions. Frog position after t seconds. This is on Leetcode 1377, one of the hard Leetcode questions. So we will go through some examples and then we will go through the logic how we can solve this problem in details and then the Java solution for this problem in today's session. But before we start looking into the problem details, I just want to mention that my channel is dedicated to help people in their Java J2E and coding interviews. So if you are preparing for any interview like Java J2E interview related materials are available on my channel, which are more than 400 different varieties of coding problems solved and explained using whiteboarding session examples and Java code. Those are the coding questions taken from previously asked questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. So if you if you are preparing for any coding interviews or Java interviews, you can go through those videos. Those are solved in details, the problems with whiteboarding session, and all the Java examples are also the code is also available into my GitHub project. So if you are preparing for interviews, this channel can definitely help you in your interview preparation. So please subscribe to this channel now. So let's start with Leetcode 1377 frog position after t seconds. One of the hard problems on Leetcode, a Google interview questions. So given an undirected tree consisting of n vertices numbered from 1 to n, a frog starts jumping from vertex 1. In 1 second, the frog jumps from its current vertex to another unvisited vertex if they are directly connected. The frog cannot jump back to a visited vertex. In case the frog can jump to several vertices, it jumps randomly to one of them with same probability. Otherwise, when the frog cannot jump to any unvisited vertex, it jumps forever on the same vertex. The edges of undirected tree are given in the array edges where edges I is from AI to BI, means there exists a edge connecting vertice AI and BI. So return probability that after t seconds the frog is on the vertex target. Answer within 10 raised to minus 5 of the actual answer will be accepted. So the problem statement is pretty clear, right? So this is kind of a graph problem, right? So even if they are saying tree, it's kind of a, we can treat it as a graph problem, and they have given us two examples here. So we'll go through these examples, but we'll first take a look at the constraint. So n is between 1 to 100 inclusive, so that's fine. Edges can be between n minus 1, right? Edges length. Edges I dot length is 2 because it is from and to edge, right? So only two elements will be there for each element. AI and BI will be between 1 to n inclusive, so that's fine. T is the time, which can be between 1 to 50 inclusive, right? And target can be between 1 to n inclusive, right? So these are the constraints. So as I was saying that even if they are talking more about like an undirected tree, we can even treat this problem as a graph problem, right? So let's go ahead and go to the whiteboard where we can go through the examples that they have given to us, right? So let me choose a pen here. So basically what they are saying is the frog is always first on the number 1 node, right? And we have one target node, in this case 4, that target is given to us, and the t is the time, right? 2 seconds. So we wanted to find out how much is the probability, what is the probability that frog can reach to this target, right, in 2 seconds. So that is what the problem is basically that we are trying to solve. So let's first go through this first example. So if the frog want to go from 1 to 2, then what is the probability of the frog going from 1 to 2, 7 or 3? The probability will be 1 by 3, correct? The probability will be 1 by 3, that it can go to 2 or it can go to 7 or it can go to 3 from 1, right? So 1 by 3 is the probability to go here, right? Now if let's say frog comes here on number 2 vertex, right? Now what is the probability that the frog can go to 4 and 6 from 2? Again 1/2 will be the probability, correct? that it can go either here or it can go here, right? Means from 2 it can go to 4, or 2 it can go to 6. So 1/2 is the probability. So if we calculate what is the probability of frog going from 1 to 4 in 2 seconds, it can be 1 divided by 3 into 1 divided by 2, correct? So it is equal to 1 divided by 6, right? 1 divided by 6. So if we calculate, it is 0.166 like this basically, right? So we have to output this probability that a frog coming from 1 and reaching to target 4 in 2 seconds. So now in 1 second it can go to 2, right? And from next 1 second it can go from 2 to 4, right? And the probability, I shown you how we can calculate the probability here, right? So so let me just remove this coloring thing. So you got the idea of what the problem we are trying to solve, right? So probability first is basically the like for example, if we want to calculate probability on this level from 1, it is 1 divided by number of his children kind of thing, right? So total 3 children are there, so probability will be 1 by 3, right? Now probability from 2 to 4 or 2 to 6 will be again 2 children, 1 divided by 2, right? But total probability from 1 to 4 will be 1/3 into 1 2, correct, which is equal to 1 6. And 1 6, if you calculate this, it comes to 0.1666 like this basically, right? So this is what we want to output. So this is the problem. So now let's talk about how we can solve this problem, right? So we will be using a very famous technique called as BFS, right, or breadth first search or breadth first traversal to solve this problem, right? So you might already know that BFS always uses queue, right? So BFS uses queue, and queue is implemented by linked list in Java, right? So we will use a queue, and what we will do is we will first create a graph from this given input, right? From these edges we will create a graph, and we will start going like doing the BFS from the node 1, right? So we will take node 1 and then put that into the queue, right? We'll put node 1 here, and its its probability. So going to 1, probability will be 1 at that time, right? Then we will go and check how many children it has. So it has 3 children, right? So we will now put the, now we will remove this one and we will put its 3 children. So which are the 3 children? 2 is the first children, right? So its probability will be 1 by number of children, right? So 2 1 by 3 is the probability. Now for 7, right, going to 7, again 7 and 1 by 3 is the probability to reach here, right? Now third is 3, right? So 3 probability will be again 1 by 3 here, right, reaching to 3. So these things we will put into the queue. Now next time again we will remove this element from the queue, right? 2 and 1 by 3 probability, and we will check what is the probability of its children. So 2 children are there. So what we will do is again we will now this probability we will get, this probability we will get here, right, 1 by 3, and we will calculate this probability 1 by 2, and then we will put that into the queue. So what we will put into the queue? 4 and 1 by 6 we will put here, correct? 4 and 1 by 6 we will put. For 6 also we will put 6 and 1 by 6, right, the probability to reach 6. So eventually we will remove this from the queue, right, in the next iteration. So basically in the first iteration we removed this, correct, from the queue. In the next iteration we removed this from the queue, right? So in first second we reached from here to here, right? And in the second we reached here basically, correct. So we will remove this 4 and 1 by 6 from the queue, and then we will keep checking if this is the target. Yes, 4 is the target that we are looking for here, right? So we will just get this probability. So the probability to reach here will be 1 by 6, correct, which is 0.1666, right? And at that same time we will also make sure that t should not be more than like 2 seconds, right? T is 2, which is given to us. So time is 2. So as I said here, 2 seconds has elapsed from 1 1 to this 2 1 by 3. This is 1 second, and from 2 1 by 3 to this one 4 1 by 6, this is another 1 second, right? So 2 seconds has elapsed, right? It means that we got from 1 to 2 in 1 second and from 2 to 4 in another 1 second. So in this case, this is how we will solve this problem using BFS and Q. So you got the idea. So we will start doing the BFS from 1, right? And we will keep putting these elements, children of 1 we will put in the queue along with its probability, right? Then again we will remove the children of this from queue and we will put its children along with the probability into the queue, right? Whenever we hit a target, we will check if it is t is equal to that same number, then we can reach the target in that with that probability in that time frame, right? Like t is equal to 2 seconds. So this is how we will solve the problem. So in this another example they have given us here is this second example. So now this example is pretty straightforward. So here 1, the probability is 1. How much probability for 2, 7 and 3? The probability will be 1 by 3, right? So we have to just return 1 by 3. This is the second example they have given us here, correct? And as you can see, t is equal to 1 second. So in 1 second we can reach the target 7, correct? Target 7 we are reaching, probability is 1 by 3, which is 0.3333, right? So so let's start looking into the Java solution now. So first thing is edges are given to us, n is number of nodes is given to us, target and t is also given to us, t is time, right? So first thing we will do is we will create a adjacency linked list or graph, right? So we are creating a adjacency linked list or graph here, and we are going through all the edges and we are populating our adjacency linked list, correct? So adjacency linked list we are creating here, and we are going from edges 0 to 1 and 1 to 0 because it is undirected tree or undirected graph, they said, right? They said undirected, so we have to go from both ways basically, right? So that's why we are adding both from 0 to 1 and 1 to 0 in the graph, right? So in this for loop now our graph is created, which is the adjacency linked list, right? After that what we will do is we will create a visited boolean array, right? Because we want to keep track of what node we have already visited, right? Because we don't want to keep revisiting it or keeping in the loop, right? So we just wanted to keep track of what we have visited already. After that we will create a queue which is holding integer array, right? It is an integer array. Why integer array? As I said here, first thing, everything in the queue, for example, let's say here for this element we will put 2, which is the node we are visiting, and the probability to visit here. That's why we need 2 elements here, right? The number of the node and the probability, correct? So that's what we are doing. That's why we have integer array. First, when we are doing starting with the node 1, the probability will be 1. So 1 1 we will put in the queue here, and visited 1 we will be true, right? Because we are visiting 1 now, and step is kind of to count the number of seconds that are elapsed, right? Like time. So step is 0 in the beginning. Here is the actual start of our BFS, right? So I'll just say BFS starts here. So we will keep doing the BFS until the queue has some elements in it to process, and the step means the time, the steps we are taking should be less than or equal to t, right? Otherwise we cannot do the BFS, right? If the step is more than t, then there is no point of doing the BFS. So we will first get the size of the queue, because that is the one thing that we always do in the BFS, right? For example, let me remove these colors so I can show you what I mean. So what I mean to say is, first the size is 1 here, correct, in the first iteration. Then here the size is 3, correct, and then this size is 2. This size is 2, right? So we wanted to know how many elements in the queue we want to process, correct, in that iteration. That's why we always read the size first, right, and then we use the for loop to process that many elements. So in this for loop we will get the the element out of the queue. We'll call it as current, and it has 2 fields, right? The node we are visiting is the first field, and the second field is the probability, correct? So b is equal to 0. We are saying b is, we are calculating the adjust, like the total number of neighbors which are not visited yet, right? Number of neighbors which are not visited, that's what we are calculating here, b plus plus, right? So for example, in this case we will have three neighbors which are not visited, right? These three neighbors, so b will be 3 in that case, right? Now after that one is done, first thing we wanted to check is, did we reach the target, right? Did we reach the target? That's what we wanted to check. Current 0 is the node that we are currently processing. Is it equal to target? And if b is equal to 0, means there are no nodes, current children or neighboring children to process, or the step is equal to t, right? If this is the case, then we have to just calculate the probability and return the probability. So here the current one element will store the number of children, not the actual probability. For example, here it will store 3, correct? Like 3. For 2, we are storing 2 comma 3 here, right? Like this. For 7 also we will store 7 comma 3, right? Then for 3 also uh, uh, we will use 3 comma 3, right? So we are actually using this, these are the number of children basically, right? So we will use that to calculate the real probability once we reach 4, right? When we are at 4, again what we will do is we will do 4 comma 2, right? So when we are processing 4, when we reach the target, we will get this 2, we will multiply this by 3, right? 2 into 3, 6 that we have stored here, and we will just say 1 divided by that 6, correct? So that's what we are doing. As you can see, 1 divided by current 1, so current 1 will be 6 in that case, right? So now in this for loop we are taking the current node and we are taking the neighbors, right? If the neighbor is not visited, we'll mark it as a visited, and we will calculate a probability basically, right? Current 1 into b. So what we are doing here, current 1 is 3 in this case, for example, and b is 2, correct? For 4, for 4 we are saying, right? For 4, so 3 into 2, 6, that's what we will store. When we are putting 4 into the queue, we will store 4 comma 6 into the queue, right? So that is easy for manipulation, that's why we are doing it. So here this time will be 6, right? Because current 1 will be 3 and b will be 2, because 2 has 2 children, right? 4 and 6, that's why, right? So after that we will just offer that w, this current element that we are processing, and we will use the temp as the probability, right? To calculate probability. So here we have walked one step, so we will increment one step here, right? So we will keep doing this into the while loop until we find the target, and otherwise if we are taking more steps than the required time, then we cannot reach that target basically. If that is the case, we will come out of the while loop and we will just return 0. It means that reaching the target within that given time frame is not possible basically, correct? So this is how we can solve this problem. Frog position after t seconds, a Google coding interview questions, a hard problem on Leetcode 1377. So what we did is, first we created a adjacency linked list or a graph using the edges, and then we used a BFS, and every step we are taking we will keep calculating the probability, right? From 1 to 2 we will keep calculating the probability basically. From 2 to 4 we will keep calculating the probability, right? So based on number of children it has, right? So 1 has 3 children, so probability will be 1 by 3 for 2, 7 and 3. 4 has 2 has 2 children, 4 and 6, so probability of 4 and 6 will be 1 by 2 into 1 by 3, right? 1 by 6 total. So this is how we can solve this problem. So let's take these examples and make sure our code works. So let's just run this first example now. So we are expecting 0.6667, which is the correct answer. It is accepted. Let's take both the examples and run both the examples now. So both the examples are running correctly. We can just go ahead and submit our solution now. So our solution got accepted by Leetcode. It is almost 48% faster than other submissions and 30% faster on memory usage, which is pretty good solution. So we have used BFS and we have used adjacency linked list to solve this problem. Frog position after t seconds. Um, so if you are new to my channel, there is a dedicated playlist on my channel called as Leetcode and Leetcode Solutions that has over 250 different varieties of solved coding questions explained with whiteboarding sessions as we just did here, with some examples and the Java code. Always the videos come with the Java code solutions, and the Java solutions are always shared in the description at my GitHub project. So if you like this video, if you find this video helpful, and if you like the way it's created with whiteboarding sessions and examples, and if this video help you in understanding this problem in an easier and better way, then please give it a thumbs up or give it a like to the video. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of the channel is to help as many people as possible in their coding problem solving by showing them how different varieties of problems can be solved with the help of different techniques and with the help of different data structures and Java. So if you like this video, please give it a like, share this video with your friends and colleagues, and to anyone who can benefit from these videos. If you have any questions related to these videos, please put your questions below the description section so that I can answer your questions. Um, Also, to become more and more confident in your interviews and coding interviews, keep practicing different problems. The more variety of problems you practice, the better you will become in coding interviews. And try not to use the IDEs. The tip is that try to handwrite the code. That will boost your confidence in real interviews. So that's just one tip from my side. And keep coding, keep learning, and thanks for watching my video. I often share different videos on different important topics and frequently asked questions. So please subscribe and hit the bell notification icon so you will get notified immediately as soon as I create new videos. Thanks for watching.